This question is all about alkanes and alkenes, so for each question make sure you pause the video, have a go yourself, and then you can resume the video and see how you got on. Question 1. Compare the similarities and differences of the two molecules below. And there we've got the displayed formulas of propane and propene. So let's start off by saying how they're similar. They're similar because they are both hydrocarbon molecules made from only hydrogen and carbon atoms. They're also both similar because they both have 3 carbon atoms. And also they are both covalent compounds, or you could say they have covalent bonds joining the atoms together. And we can tell that because each of those sticks in the displayed formula is a covalent bond, and also we've got 2 non-metals joining together, hydrogen and carbon. Now we'll go on to see how they are different. So they are different because propane is an alkane and propene is an alkene. And we can see that because propene has that double bond. We can also say propane has only single covalent bonds between the carbon atoms, whereas propene has a double covalent bond between 2 of the carbon atoms. There's other differences we could talk about. We could also say propane is a saturated hydrocarbon, whereas propene is an unsaturated hydrocarbon. Saturated means there's only single covalent bonds between the carbon atoms, and unsaturated means there's at least 1 double bond. And propane has the general formula CnH2n plus 2. That means if you want to work out the number of hydrogen atoms, you double the number of carbons and add 2. Whereas propene has the general formula CnH2n. That means to get the number of hydrogen atoms, you simply double the number of carbon atoms. Question 2. If you had a bottle of hexane and a bottle of hexene, but the labels had fallen off, what chemical test could you do to find out which one is which? And that would be worth 3 marks. Well, it's the bromine water test. So you need to add bromine water to each substance. If the bromine water stays orangey brown, that must be the hexane, as it's an alkane. If the bromine water changes from orangey brown to colourless, that must be hexene, as it's an alkene. And you must say in questions like this what the colour change is. You can't just say if there's a colour change, you need to actually say orangey brown to colourless. If you're finding the video useful, please take a couple of seconds to give it a quick like. Number 3. How would the properties of decane be different to the properties of hexane? So we need to spot that decane is a longer hydrocarbon because it would have 10 carbon atoms, whereas hexane would only have 6. So you need to remember the differences in the properties as the alkanes get longer. So compared to hexane, decane would be slightly more viscous, that means not as runny. That's because as the molecules get longer, the forces between the molecules get stronger. It's also less flammable. If you could burn it, it would burn with a smokier flame. And it would also have a higher melting point and boiling point, again because those forces are getting stronger between the molecules. So it would take more energy to overcome those forces. And as we get longer hydrocarbons, they become slightly darker in colour. So decane would be a slightly darker colour compared to hexane. And the last question, sort the following into 2 groups, alkanes and alkenes. So you need to remember those general formulas. If it's CnH2n, it's an alkene. If it's CnH2n plus 2, in other words, double the number of carbons and add 2 to get the hydrogens, then it's an alkane. And when we do that, we find that C3H6 is an alkene, C5H12 is an alkane, CH4 is also an alkane because if you double 1 carbon, that's 2, and add 2, you get to 4 hydrogens. C2H4 is an alkene, C4H8 is also an alkene, and C3H8 is an alkane. So don't forget to subscribe to my channel so you don't miss out on future videos. Thank you for watching.